Okay, the first section of solving systems equations by graphing. First off, knowing what a system is. So a system is where we're going to have two equations and we're going to graph both of those on the same coordinate plane. There's different methods that you can use in order to solve these, but the first one is we're just going to be graphing. So remember, this is in slope-intercept form. So my y-intercept is at -2 and my slope, it doesn't have one written there, but I can go ahead and put in that invisible 1. So now I can put it into a fraction as -1/1. So then if I came down here to my graph, I would go ahead and plot my y-intercept on the y-axis. So that's at -2. My slope is negative, so that tells me I'm going down 1 and right 1 since it's 1/1. So then I'm drawing in a nice straight line. You have to make sure that you have several points because you're going to find their intersection. So make sure you keep going in both directions. So I went down 1/1 until I hit the bottom, and the same thing up there. Now we're going to go ahead and plot the second equation. So y equals 2/3 x plus 3. My y-intercept is at 3, so I put a point at 3 on the y-axis. And then my slope is at 2/3. So then I'm going to go ahead and go up 2 from my y-intercept and over 3. I'm going to keep doing that. Obviously my lines are not going to intersect over here, so now I'm going to go in the opposite direction and go down 2 and over 3, and then I find my intersection point. Where they intersect is my answer, so then I find the coordinates of this point. So starting at the origin, I would go left 3, which is why my x coordinate's -3, and I go up 1, so my y coordinate's 1. So here is my answer. So you're going to pause the video and try number 2. Okay, on number 2, it has y equals x. If you like putting in those numbers, go ahead and put a 1 in front of that x, and then you can put a +0 behind there. So then you're going to graph both of those. So graphing this top one, I put a point at 0 on the y-axis, and then I would go up 1/1 until I hit off, and then I would do the same thing going down. Then I would come back and graph the second one. So I should have a point at +6 on the y-intercept, and then my slope again is -1, so I'm going down 1, right 1, until I find my intersection. Here is my intersection point. So then from the origin I count for those coordinates. So I went right 3, so my x is 3. I went up 3, so my y is 3. Okay, so what happens if it's not in slope-intercept? So remember, if it's in standard form, you're going to go ahead and do the cover-up method. So we're still going to graph it, just the method will change. So if I cover up the x in the first equation, I would end up with just x equals -1. No solving needed. Then I'm going to come back and cover up the x to find the y-intercept, and now I would need to solve to get rid of this negative in front of there. So I would have to divide both sides by -1. So then when I divide -1 by -1, my y-intercept's +1. These are the ones where you have 2 points. So my x-intercept is at -1, so I have a point here. My y-intercept is at +1, so I have a point here. We only have 2 points, so it is crucial that you have a straight edge and you're drawing an absolute straight line so that we can find that intersection point. So then for the second equation, x plus y equals 3, I would cover up the y, and so I would get x equaling 3. I cover up the x, and I get y equals 3, so there's really no solving to do. So then my x-intercept is at +3, my y-intercept is at +3, and then again with my straight edge I'm drawing a nice straight line, and then I find their intersection point, which is here. I start at the origin to count those coordinates, so I go right 1, up 2, so my point would be at 1, 2. You're going to pause the video and try the last question. On the last question, here is your original, so double check your intercepts. You should have covered up the y and got x-intercept at 12. When I covered up the x, I got -2y equals 12, so I would have to do some solving and divide both sides by -2, so my y-intercept's at -6. Then for the bottom one, I have to cover up the y, so I have a I have -3x equaling -1. I would divide both sides by -3, And looky there, I end up getting a fraction or a decimal depending on which you like to write, which is okay. Then for the y-intercept, I covered up the x, so I get y equals -1 and no solving. Over here on my graph, for this top equation, x equaling 12, I had to extend my graph out 2 spots to put 12 on there. And then for y equaling -6, I went on the y-axis at -6. With my straight edge, I drew the best ability of drawing a straight line. Then for the other set, I had 0.3, so that means I'm going to be at about 1/3 of the way between 0 and 1. So if I cut that into 3 sections, here would be about 1/3. Then I have at -1 for my y-intercept. Again, I need a straight line because these need to match up so I can find their intersection. So here was their intersection. Then I count from the origin those coordinates. So -2 for my x because I went left 2. And then I went down 7, so my y-coordinate would be at -7. So it is okay that you end up getting a decimal or fraction for some of your intercepts, but you do need to be careful and do your best to draw a straight line in there because you want to find their intersection. Okay, that's the first part of solving systems by graphing.